Let's take a deep dive into Rich Sutton's The Bitter Lesson, an explanation of how artificial intelligence research, leveraging enormous computing power, has beaten AI research trying to leverage human knowledge every time. Courtesy of Moore's law, computing power has skyrocketed over 70 years, while its cost plummeted, enabling incredible breakthroughs in machine learning, leading to our present era of large language models and other powerful AI tools. Human knowledge has not only been eclipsed at every step, it has largely only gotten in the way, diverting resources and attention from leveraging more compute, while also creating systems less ideally designed to use those immense computational resources. Sutton calls this a bitter lesson, but I see it as a hopeful one. We already have the means in hand to make immense progress, and our greatest challenge is simply getting out of our own way. This perspective doesn't dismiss the value of human knowledge, but it's human, and what makes us different and special is exactly why it doesn't simply map over to circuits in silicon. But by ending our own self-sabotage, we can turn these unfathomable resources not only to improving AI, but to better understanding the human mind as well, which makes the bitter lesson a sweet remedy for us all.
All right, so get ready, because today we're doing a deep dive that's going to totally change how you think about AI.
Yeah, this is a big one.
It really is.
We're talking about this idea from a top AI researcher that basically says all this effort to make AI more human-like,
Yeah.
it might be the totally wrong way to think about it.
Totally. And what's crazy is this isn't just some, out there theory. This is coming from Rich Sutton.
Exactly.
This guy is like a legend in AI. I mean, he basically wrote the book on reinforcement learning.
Yeah, literally wrote the book.
So when Sutton talks, people listen.
The whole AI world listens.
For sure. So we're diving into his paper, The Bitter Lesson. And let me tell you, it is a wild ride. It challenges everything we think we know about building smarter machines.
It really does.
So to get this, imagine like a chessboard.
Right.
For decades, everyone thought the only way to beat a chess grandmaster was to teach computers to think like humans.
Right, because that's what we assume intelligence is, right?
Exactly.
Thinking like us.
So anticipating moves, strategizing, all that.
Yeah, like a human would.
But then Deep Blue comes along.
And just demolishes Kasparov.
Crushes him.
And not with some genius strategy.
Right.
Just pure brute force crunching millions of moves per second.
Way more than any human could ever do.
Oh, yeah, by far.
So, okay, brute computational force wins in chess.
At least in chess.
But is that just chess? Or is there something bigger going on?
That is exactly what Sutton's bitter lesson is all about.
Okay, I'm intrigued.
He says this isn't just a chess thing. This is a pattern we see across all of AI. Look at Go. Even more complex than chess.
Oh, absolutely. Go is next level.
Way too many possibilities.
Too much for my brain to handle.
Exactly. And for the longest time, experts thought Go was impossible for computers to crack with brute force.
Right.
So they focused on encoding human strategies.
Interesting.
All those heuristics.
Trying to program in that intuition of a Go master.
Exactly. Instead of letting AI figure it out.
Find its own way to win.
They tried to make it play like us.
And what happened?
Well, progress was slow. Super slow.
Really?
Then Google DeepMind comes along, creates AlphaGo.
Okay.
This wasn't about mimicking humans. AlphaGo was all about deep learning, reinforcement learning.
Interesting. So it played millions of games against itself to learn.
Exactly.
Okay, this is where it gets really good. Tell me it learned to dominate Go.
It did. AlphaGo didn't just beat a professional player, it beat Lee Sedol, a world champion.
Wow.
This was considered impossible, just a few years before.
That's a huge deal.
It was a major victory, not for human knowledge crammed into a machine, but for raw computational power and smart learning algorithms.
So we've got chess and Go both showing this pattern. Brute force computation plus learning beats out trying to mimic human thinking.
It's a trend.
Are there other examples of this bitter lesson popping up in AI?
Absolutely. Look at speech recognition. Remember those early systems?
Oh, yeah. You had to talk like a robot.
Exactly.
Oh, yeah.
You had to speak in these robotic phrases just to get them to understand. Back then, researchers were trying to program in all the rules of language. Phonetics, grammar, you name it.
Because that's how our brains do it.
Exactly. They figured that's how AI should do it too.
Oh, I remember those days. It was rough. You practically had to talk like a robot for it to get you.
It was all about forcing the machine to think like us. But the real breakthrough came with statistical methods, specifically hidden Markov models.
HMs.
Yeah, HMs.
Does that stand for hugely more mind-blowing?
Live. Not quite. But they're a major shift in approach. HMMs don't understand language like we do. Instead, they analyze massive amounts of speech data, looking for patterns and probabilities
Interesting.
to predict the most likely words being spoken.
So more data, more computation, better results.
It's a recurring theme.
It's starting to sound familiar.
And this paved the way for the deep learning revolution we see today. Now we feed deep learning algorithms massive data sets of speech, and they learn the complexities of language on their own, finding patterns and nuances we could never program directly.
And the results are amazing. Voice assistants, real-time translation AI that can generate incredibly realistic sounding speech.
It's incredible.
It really is. It's like magic.
It's the bitter lesson in action. By letting go of the need to program human knowledge directly and embracing the power of computation and learning, we've unlocked insane advances in speech recognition. And believe it or not, the same thing happened with computer vision.
Computer vision, so like teaching computers to see.
Exactly. And early on, it was all about trying to copy the way we see the world.
Right.
Researchers breaking down visual information into these rules a computer could understand.
Okay.
Like identifying edges, shapes, objects.
Yeah.
But our visual system,
just so complex.
insanely complex. Trying to program all of that, it's a huge challenge.
I bet our brains do so much visual processing without us even realizing it.
Stunning.
Doing that into code, just thinking about it makes my head hurt.
And that's exactly where the bitter lesson comes in again.
Okay.
Instead of painstakingly programming every single rule of how researchers turn to deep learning.
Makes sense.
So they feed these massive data sets of images into artificial neural networks.
Okay, so these are basically
Think of them as complex systems, kind of inspired by the human brain.
okay, I'm with you.
And by doing this, they could train computers to see and recognize patterns on their own.
So instead of trying to explain to a computer what a cat is,
Right.
by defining all its features, like whiskers, ears, tail,
All those details.
we just show it a zillion pictures of cats and let it figure it out.
Exactly. That's the idea.
Wow.
And the results have been incredible.
Really?
I mean, think about it. From facial recognition
Okay.
to medical imaging,
Right.
self-driving cars, this stuff is everywhere.
It's true.
And it all comes back to this key shift, right? Letting go of that need to program human knowledge directly.
Yeah.
And instead, embracing the power of computation and learning.
So fascinating. Okay, I'm convinced Chesco, speech recognition, computer vision, the bitter lesson is definitely real.
It keeps popping up.
But here's what I don't get. If history keeps showing us that this brute force computational approach with smart learning wins, why do we keep falling into that trap of making AI think like us?
That's the million-dollar question, isn't it?
It really is.
Sutton calls it anthropocentric bias. Basically, we can't help but see intelligence through our own human lens.
Right, because that's all we know.
It feels natural to think that building a smarter machine means making it think more like us.
Totally. It's like we're projecting our own experience onto AI.
Exactly. Like if all you have is a hammer, everything looks like a nail.
And there's something kind of satisfying in it, too.
There is.
Like seeing a machine think the way we do.
It's like it validates our own intelligence.
Yeah.
But as we've seen, that approach might be holding AI back.
Interesting. So then what's the alternative? Where do we go from here?
Sutton says we need a fundamental mindset shift.
Okay, I like where this is going.
Instead of asking, how can we make AI more like us? We should be asking, how can we unleash the power of computation and learning to create AI that surpasses us?
So less about mimicking ourselves and more about giving AI the tools to chart its own course.
Exactly. Even if that means it goes beyond what we're capable of.
Okay, so we're not saying we should just ignore human knowledge altogether.
No, not at all.
Yeah.
It's still crucial,
For sure.
like for setting goals,
Right here.
providing the right data.
And I'd imagine understanding what AI does with all that.
Exactly. We need to understand the implications of its actions.
So it's like, we're the teachers, but we need to be okay with AI becoming the student that surpasses us.
I like that analogy.
It's a good one?
We need to realize that the real driver of progress in AI
Yeah.
is going to be these general methods. like deep learning, reinforcement learning.
That can actually use all this incredible computing power we have.
Exactly. And that power is only growing exponentially.
So it's like less about like cramming AI full of specific knowledge.
Right. It's not about that.
And way more about building these systems that can learn and adapt.
It's at a scale that like we can barely even imagine.
On a scale that we don't even fully grasp yet. And that's where things get really interesting.
Okay, I'm right.
If intelligence isn't about what you know,
Right.
but about how you learn,
Okay.
then what does that mean for AI? What's possible when machines can like gobble up information and learn from it way faster than us?
Right, at speeds we can't even comprehend.
Exactly. It's a huge question.
Yeah.
Not just for AI research, but for like all of humanity.
It's kind of a lot to think about.
It really is.
Okay, so bringing it all back to the bitter lesson.
Yeah.
Sounds like we need to like totally rethink how we see AI, you know?
And get a new perspective.
We've been so focused on recreating our own minds in a computer.
Trying to build a digital version of ourselves.
Exactly. And we might have missed the real path to truly intelligent machines.
Which is
Embracing that power of computation and learning, letting AI learn.
letting it surprise us.
It's a powerful message. It feels like this is a turning point in AI.
I think a lot of people in the field are starting to realize this.
Yeah.
We're still figuring out what AI can really do.
Right, we're just getting started.
But the approaches that seem most promising,
Yeah.
they're not what we thought they'd be.
It's exciting and also kind of humbling at the same time.
Totally.
Like, we think we're so smart, but maybe true intelligence is something completely different.
Something beyond our understanding.
Yeah, exactly.
Yeah.
So, to everyone listening, here's something to think about.
Yeah.
If Sutton's right and intelligence is more about how you learn,
The process, not the knowledge itself.
what does that mean for us humans? How can we use these same principles
Of learning and adapting.
to thrive in a world that's becoming more and more shaped by AI?
It's a question we all need to be asking.
For sure. And on that note, that wraps up our deep dive. Thanks for joining us.